Welcome to Cpp.chat, a modular look at what's going on in the world of C++, chatting with guests from the community. But before we build up to this week's guest, John has something he needs to say.
Thank you, Phil. The website and the information contained herein is not intended to be a source of advice or credit analysis with respect to the material presented, and the information and/or documents contained in this website do not constitute investment advice. So our guest today is Izzy. And Izzy, you got a lot of stuff going on. I know you've been involved with the standards committee. You've spoken at a number of conferences, but I more or less think of you a lot as a tool person, building tools. But I don't think that's your day job right now, is it? You want to tell us what you're doing now?
So actually, a part of my day job involves building tools, but it is not my primary focus. So I'm a distributed systems architect at Netlify. We're a San Francisco-based startup, although we are 40% remote, and we do basically what's known as Jamstack. It's a newer approach to building websites. So if you're familiar with using things like Jekyll or Hugo or more classic, well-known static site generators like, say, Sphinx for like documentation, it's kind of related to that, except that you're then able to make more dynamic content. So you can actually have like a full user login and authority system. And then we basically take care of all the, building of that and deploying of that so that, you can focus on your website and not having to focus on the CI, the deployment, getting statistics and login and all that jazz. So, and I work on the C++ side of things because we use C++ on the back end for serving a lot of the content.
So, so that's service. You're not selling the server. You're selling the service.
Yeah, we're selling. It's software as a service. Yeah.
Yeah. Right. Okay.
So.
All right. And how much of that is C++?
So I can't give the. I don't think I was clear to give the accurate number, but we, every request does eventually go through a web server that is just written in C++. We do have a bit of Rust code that we started to deploy. I'm not typically involved on that side of things, although I've been helping out a little bit, but I'm not like the main Rust person. That's my coworker. But I came in and basically they needed someone that knew both C++ and a bit of Rust, so I can do both. And that's kind of, I straddle that line these days, although I'm writing way more C++ now with C++, 20 being available thanks to Clang 10 and GCC 10 than, when I was writing like C++ 17, where I was kind of writing like a little bit of both. So
I want to get back to tools, but first I want to talk a little bit about web, because I think that C++ isn't terribly well represented in the web world. I mean, we don't think of C++ as something you'd build a website in, although obviously you could. And in fact, most people who are doing web stuff are doing it either in Python or Node.js or something like that. Yeah. So, but I'm convinced there's a role for C++. Maybe more on the infrastructure side than on the content side, but there's definitely a place for that. Am I wrong on that?
You're not wrong. I mean, like there's a lot of existing web servers out there that are in C++, and I think one of the biggest issues is like if you want to use Node.js, you go and you get Node.js. But I kind of referenced this in my 2017 talk at CPPCon. If you want to get started with C++, you have to figure out what build system you want to use. You want to figure out what compiler you're going to use, what platform you're targeting, what version of C++ you're going to target as well. And then you have to also deal with, grabbing dependencies and figuring out how those dependencies are going to interact and, trying to find the minimum common denominator. Whereas with, Node.js, you say we're on LTS 12 and we will deploy from there. Or if you're using Golang, you just compile your static library, you compile your static executable and you deploy and you're done. And it's less about the tools and more about writing code for the average person. Whereas there is an argument to be made that for a majority of C++ people, especially people on the committee, a majority of us are writing libraries and not full huge products always. And I think the arguments you'll see on Twitter between standard C++ people and game dev C++ people, it's kind of evident that there's a definitely split there with you know, the priorities for different people's you know, like what they would like the language to have. So that might be partially why is that, you know, when you're writing a website or a server backend, you know, it's easier to write it in Python because there's a Python package manager, and then, you know, same with everything else, except for C++ because we have, like, I think we're up to 6 now for the most commonly used ones. So
yeah, I think that's a real advantage. C++ has more package managers than anybody, right?
Yeah. Quantity over quality, right?
That's right. That's right.
Yeah.
That's right. Yeah, there should be an XKCD in there somewhere. Yeah. So let's obviously this gets us back to the tooling side. So you have spent a lot of time in build as a build tool, working on build tools.
Yes.
Is that what you're working on now? You kind of hinted that you're still doing some build stuff. Is it build tool? I mean, some tool stuff. Is it build tools or other kinds of tools?
So I haven't gotten to build tooling yet. We actually have a dedicated tools team, but they're, you know, for the entire organization.
Yeah.
But because you know, they're busy dealing with the entire organization, really wouldn't be fair for me to be like, hey, can you just go and solve all the problems for C++ build systems for me? Thanks. So I do handle most of the CMake related things. We do use CMake. We don't have a package manager at the moment. Because everything's mostly contained with our dependencies. And, you know, I also for the last 2 years, I've been writing this thing called IXM, which is stands for Izzy's extension modules. The website and the actual like implementation that's available right now, it's not even pre-alpha, it's broken. I broke it on purpose specifically so that no one would use it because it's not ready yet. But the idea behind it is that you include this into your CMake file, and it will automatically generate most of your project based off of where your files are located. Kind of like a, you know, Vector Bool, Colby Pike, who I think was on the last episode. If I
maybe the last one that was published, but I don't know.
So, but kind of like his, you know, his pitchfork idea, except I went in a different direction with my directory layout and tried to coincide things with, or not coincide, but kind of align them with the way that Rust is, because the Rust directory layout is very close to how, you know, C and C++ projects have been done over the years. And mine's a bit more like, well, if you don't want, you know, this to do it for you, then you have to do it yourself. But like, we're not going to get in the way and be, you know, extremely strictly forced with where things are located. So that's some of the tooling stuff I've been doing, and then also, you know, starting to do more stuff with GitHub Actions, which is JS stuff, and then I'm also just kind of tired of CMake's CLI, so I started writing a wrapper around it so I could also get the JSON data, because CMake can produce JSON info, but it produces it in this very weird way where you have basically multiple arrays of objects, and you have to like constantly do like cross-referencing lookups. So I just want it all as one massive JSON object, and I don't currently get that with with the default CMake. And I just want to be able to type, you know, tool name configure, tool name build, tool name test, and have the test also build my unit tests, as opposed to, well, they weren't built, so I couldn't find them, so the test run failed, which is, you know, a problem with CMake. And you know, just like the last 2 years, I've kind of learned a lot about the internals of CMake, to the point of, you know, I wrote a like, here's a list of cursed things you can do with CMake, kind of a thing. Like, you can set emoji variables, which, like, you know what? If you can't set something to the poop emoji as a variable, is it even a modern language? I don't think it is, right? If Perl can do it, why can't CMake?
You know, I haven't really given this much thought, but it occurs to me that, you know, kids today, those of us who have gray hair can say, kids today are gonna want to use emojis in code. And while I think it's really cool that that's technically possible, I kind of think that's a bad idea.
It's terrifying, because, like, you know, what's the next step? Are we going to have Fortnite dances as variables in our languages? I don't know. And if that ever happens because someone heard this and they're like, "Oh, I bet I could do that," please,
Yeah.
please don't show it to me, because I don't want to know that I'm responsible for that idea going out into the world. But
I'm sorry, I should let you go, but I'm horrified. I think about this when I'm chatting and I hit the little button to show me emojis I could send, and it's like there's like 24 of them that just look like faces, and they pretty much are all the same to me. Oh no, this is a half grin, but this is a grin, and this is a, Can you imagine trying to keep that straight as a variable? That's like,
yeah. Well, the best thing too is that, depending on what font you're using or what encoding you're using, it may not show up as emoji, which is a recent discussion I think the C++ standards group was having about how technically internal coding of character sets is implementation defined. So technically speaking, yes, it could work with emoji, but whether it actually treats it as emoji or not is entirely up in the air. But you can always ask Corentin for more info on that. He knows way more about that stuff than me, and I do not want to peek into that nightmare. I'm busy with CMake cursed stuff at the moment. But it's actually been useful for me because most people can't type emoji immediately into their editor. So when I want to have internal variables, I actually use so this is an example because I know how CMake's variable stuff works. To dereference an emoji variable is actually impossible in CMake, because you have to, if it's not inside of like A to Z 0 to 9, like dash underscore plus and slash, you have to put a backslash in front of it. Well, that means you have to put a backslash in front of each of the bytes that make up that emoji, which you can't really easily do. So it means you can make an undereferenceable variable, and you can only let it be used in places where CMake has to do the dereference for you, like an if statement, a while, a for each. Or where I use it most is with properties. So I set a lot of properties because it turns out under the hood, CMake, so for strings and variables, they're all stored in this massive list, and it has to dereference them and do like multiple lookups sometimes. And it creates like this whole machine to like dereference things. And then when you use set property or get property, it just uses a hash map underneath the hood. So it's way faster to just set properties on everything, including your targets and like globally, your directories, your projects, all that jazz. So that's what I do. And if I have an internal property I don't want someone to use, I use the reserved emoji, which is is from the original emoji set from Japan, where I think it's technically the Japanese character for reserved. You typically see it with the Japanese character. It's got a green background and it says reserved on it. I think that's meant for reserved parking, but I actually haven't looked into it. But I put it in front of all of my internal variables so that if someone was to use it, and they submitted that as part of a code review for their CMake, like someone would probably be like, "Why is there an emoji here? What are you doing?" And hopefully that would like prevent them. Or if they had that discussion, that the person would be like, "Maybe we shouldn't touch this." That's kind of like the goal that I'm going with is like, if you see this and it just gives you like a weird vibe, like maybe just don't touch it. It's kind of like a Legends of the Hidden Temple / Indiana Jones thing. Like, hey, that looks a little weird. Maybe don't touch it. So that's what I've been doing a lot of. And then I've been kind of going around to various projects. I've had to take a break from that because I started my job, and then there are a lot of things happening in the world at the moment. But I was going through a various number of C++ and C projects that I like YAML CPP. I improved the build times there because it turns out whenever you have an if statement in a CMake file, it has to create an entire parser from Bison and Flex to parse it, and then it destroys it, and then it moves on, and that's like a lot of processing time. Or you can put it into a generator expression for most things. Like if you're like, okay, if I'm on Windows, use this flag. Otherwise, if I'm on Linux, use this flag, kind of a thing. So reducing branches in your CMake file means that your build configure step runs faster, and CMake's configure step runs single-threaded, whereas generation, it can technically run multi-threaded. So like while it will only generate one build file per like target. If you have like say 100 targets and you have to do an if statement for each of them, that's going to be very slow. But if you have this so-called generator expression, which is like what if Lisp but worse, in the same way that CMake scripting language is what if Tickle but worse. The generator expressions can run multi-threaded, so it's because it's just reading data and it just performs string transformations, and it's not having to stop everything, check a bunch of state, and then produce an output or branch. So doing that speeds up projects dramatically, and some of them have been kind of tough because like they may have like a project upstream that ruins things, or it makes it very difficult, or I can't just like rewrite the whole file for them because otherwise like no one understands this now. So I have to do piecemeal changes over time. But I was able to get YAML CPP. I'm going to mispronounce this, and I apologize to the author in advance, but it's like a PUG XML or PUGI XML. I also started targeting libuv. And I had to take a break from it for a bit, but I was helping some of the Node community. They want to move off of the build tool that they have right now, which I'm not going to pronounce its acronym form because it's technically a slur against people who are Roma, which I'm not even sure if I technically should be saying that word either. But basically, the tool is called Generate Your Project. And it was originally used by Chrome. It's no longer used by Chrome because they moved on to something that was better. But Node kind of stuck with it, and they kind of want to move to CMake. So getting, say, V8 to build with CMake would be really advantageous. And so I've been also helping to get V8 to build with CMake. But I've been able to touch that since February because, again, I started my new job and all this other stuff. So it's been a lot the last few months. So been trying to stay busy.
One of the things you said you have been using C++20.
Yes.
Or
at least
working for you?
as much as we can use it. There's concepts. The library is not in Clang, so having to implement most of it has been fun because I have to go through and be like, okay, so to implement this, I have to implement half of ranges. Cool. Is the type swappable? Well, first off, do you have ranges swap available? No. Okay, implement ranges swap. Great. So having to sorry, 1 second there. No? Okay. I guess my camera's just stuck like this now. Now, yeah. So it's been useful in that I'm having to learn more about the details of the standard with regards to concepts, and also as a result ranges, which has then given me some ideas for a few papers. Like in the standard, we have is same, the type trait, and then there's same as, which is the concept version of that. Although there's some details there about subsumption and other stuff that I honestly don't entirely understand because the term subsumption is not defined in the standard, and I just kind of assume that you know what it means. But in the standard, we have a lot of instances of not same as. So, whenever we have a std any, right? If it takes a templated T, you have to make sure that type is not a std any. Same thing with optional. Like, is this you have to make sure that this specialization of optional coming in is not the same one as myself, kind of a thing. And so you end up seeing a lot of this not same as, and it's like, well, why don't we just add that to standards everywhere? So why don't we just have a std different from, which is just not same as. So that's a paper I'm going to be submitting sometime, hopefully for the July.
So were you saying, wait a minute,
proposal?
Sorry, you
Go ahead.
Distracted me. I saw a squirrel running by, and squirrel. Can an any of T not hold? Can T not be an any of something? Can an any not hold an any?
An any?
You're saying in a particular context.
So if I want to copy an any, then and I want its copy constructor to run, I don't want that any to store another any, right? I want it to copy it. I don't want it to just like take it and then maybe allocate space for an any, because then you end up with an any of an any of an any of an any, right?
Yeah.
Maybe like an int, right? So, because that's just wasteful. So you need to check to make sure that it isn't doing that. Technically speaking, I think there's a dot in place, so you could have an empty any and then do any dot in place, another any, and then it will store the any. But also, why would you do that? Don't do that. So yes, technically an any can store an any, but why? Okay, I don't understand.
Well, what you're saying is syntactically, naive attempts to do this will not.
Right. And that's the thing. Like I discovered back in 2013 when like these papers were first coming out. I was like, oh, I need to like prevent this from happening, and we'd use like enable if not is same as, or not is same v, kind of a thing. It's a very common like construct. So, saying requires different from myself, right? Like decal type this is necessary, and you have to like do remove cbref and all that other stuff. Actually, I think Vector Bool is in the chat there saying alike and unalike. But my point though is that like I need not same as, which is different from not same as remove cbref t, because that gets used a lot as well. So although originally it used to be decay t for all that stuff, and then we finally added remove cvref because we realized, oh wait, that actually breaks a lot of stuff. So just small things like that. Yeah.
So what is the advantage of, did you say different from?
Yeah.
Versus just the not same as?
Yeah, it's the inverse. One of the nice things is that instead of, because like right now with concepts, right, if I want to have an abbreviated concept, like template parameter, right, like I can write template destructible t. I cannot write template not same as, void or something like that. So I need to have some way to say, okay, I need this to be the inverse of it, so I can just have an abbreviated form, because one thing that is an IFNDR, ill form no diagnostic required, is if you have two concepts that end up having the same requirements or they're ambiguous, the compiler technically doesn't have to say that it selected the wrong one. Or if you want to like, there's like a specificity to concepts of like, it's kind of, I hate to say this, but it reminds me most of CSS selectors. There's like a level of selection and preference. And so the more specific your concepts are, the easier it is to select. And that can involve things like, compound concepts, which I personally enjoy way more than having to put parentheses around my entire expressions. Just having, I think for some of the basic ones where it's a Boolean like concept where it's basically being taken from a type trait that was an is, underscore whatever. Yeah. Having an inverse of that tends to be fairly useful, I think. So like there's the proposed is specialization of. Sometimes I need to make sure it's not a specialization of some type, because I wanted to do something different. And having that as a concept allows me to be more specific. It makes it easier for me to implement a Neebloid or something similar, or even just like for a tag invoke kind of a thing. And I just end up saving time, because then when I go to write my actual code, I'm just putting, concept name, auto double ref, variable name, and I'm done. I don't have to put a, requires after it. I don't have to, do a requires, no accept. I just have to do that one line, and I still have to do the no accept, but still, like it's we haven't solved that problem yet. But like, if honestly though, if that concept was also marked as no accept, like then I actually don't have to repeat the no accept, right? So there's like a lot that I think could be gained from just having some inversion. I'm not saying all of them need to be, because a lot of them are not just a simple like this is not destructible, right? It's more of just like, is this the base of, or derived from, or not derived from? Like are they siblings kind of a thing? I'm not doing the wording here too well, but like I'm just kind of spitballing ideas. But that's the thing that I've noticed, is that we kind of need some inversion of things. Like we have signed integral and unsigned integral. What other type of integral is there? Well, there's the built-in ones of like, char and stuff like that. But those are like, that's because of C, right? Like that's not a decision that we willingly made. So it's nice to be able to say like, there's an inversion, just switch off of them, and it ends up being more readable, especially for juniors. or people not coming from C++, like being able to show my concept code to people on my team who are not well versed in C++, who do, occasionally mess up with lifetimes because they're used to the Rust borrow checker saving them. Being able to show them concepts and be like, hey, like this is going to save you, and they're like, oh, okay, this is like way easier to read than this template metaprogramming garbage that you've showed us before that like made me dread working with you. I was like, oh no, that was just for fun.
Yeah, right.
That's not gonna get for the production. That's for fun. That's for me.
C programmers have a twisted idea of fun.
Yeah.
C++ programmers, I mean.
Yeah. Well, C programmers
just as a sidebar, you mentioned tag invoke and Nebloids. If you don't know what those are, anyone listening, Gashbert Usman just did a talk at C++ London, which is up on YouTube. I'll put a link in the show notes. Really interesting stuff.
I actually watched that last night because I've just been calling them customization point objects, and I was like, oh, this is way cooler than what I've been having to do with like priority dispatching and kind of sort of hoping it works and seeing that it does. But the tag invoke stuff would save my bacon. Although in the case of some of the CPOs in the standard, you still need to do tag or not tag invoke. You still need to do priority dispatch, but that's like swap begin and end.
Right.
Oh well.
So in part of your use of 20, are you using modules, and how do you feel about that?
So I'm actually trying to make sure that our headers will be able to move over to 2 modules when that's available through build systems. However, I personally think that while modules, the feature will be available, build systems and tooling for them will not be at a state that we're ready until the tooling TR comes out. Which I finally called into one of the meetings because I finally had time one day. Unfortunately, a lot of the standards community is doing a lot of telecons at the moment, and a lot of those are scheduled at the exact same time that I have a morning stand-up meeting. So I have not been able to go to many of them. I'm trying to keep up with the notes and stuff like that, but there's something different about being there and being able to bring something up at the last minute. One personal victory I'm very proud of is I've been having this argument for I think since Hawaii. So Kona 2019 was which is when they announced it. The file paths were going to be originally a list of numbers in JSON, which makes sense for you need to worry about UCS2 and bytes and stuff like that. But JSON is supposed to be human readable and machine parsable, and it isn't when you have to do stuff like that. And so I've been making the argument of well, just if I can say ASCII is what I just want to support as a build system, why can't I? So the actual wording isn't in there yet, but we will have a if your build system wants to support more than just basic UTF-8 or something like that, it will tell you, but the bare minimum will be basically ASCII characters, which is what most of us currently use anyways. So we don't use modules at work yet because there's no build system that supports it. We're using CMake. We're on 3.16. We went to 20.04. So we don't have, the ability to actually use them. I'm feeling way better about them than I did in 2017. Things are getting better every time I see them. I'm still a little mad that, I can't do piecemeal importing of something. So someone is being lazy with writing their module because they couldn't get it to work and they export everything and they didn't namespace it. That can cause issues for me if I want to have say a nameless namespace in my implementation module. And if I only want to re-export, because we now have this concept of reachability and visibility. If I want only some of their API to be reachable versus visible, I can't really do that at the moment. I can't say, okay, I want to import all of type traits from the C++ standard library, but I only want to re-export, is same v and is base of. And at the moment, we might be able to fix that in the future, but by not having it up front, it makes it a bit more difficult to add that in later, because if we want to add it as a keyword or as a syntactical thing, a lot of tooling out there is going to then have to be updated, which if it doesn't get updated, then you can't use it to begin with either, because we have to scan our dependencies. We're kind of back to 1995 having to, make deps. So it's unfortunate that didn't seem to cross anyone's mind at any point. And also I wasn't smart enough to write a paper at the time, because there's a lot about modules that, I still didn't understand at the time because I was still learning. And then also I personally want to kill the preprocessor. So it's cool that we could have, if defs now, but I just want conditional imports that would solve so many problems. We wouldn't have to really argue about static if all that much, because you just say, well, if you don't import it, then it's not available. Problem solved. It's just removed from the entire, syntax tree entirely. But that's going to complicate build systems even more if we add it later on. So it's better, but it's not where I wish things were.
So we have the breaking story that you're not entirely pleased with modules.
It's gone from I am upset and angry to I'm filled with what's the word? I'm filled with ennui. I am very blasé. It's a meh. Coulda, shoulda, woulda. I'm gonna have to live with it, and if things don't work out, I'm glad that I was able to learn Rust, because I can always just run to that community where modules and namespaces are basically the same thing. Yeah.
So what about C++23?
I'm looking forward to it. I know that 20 technically hasn't been published yet. We still have till the end of the year, and I wasn't able to get a few papers in just because we had so much wording to go through in, say, Kona. I wasn't able to make it to Prague because I had quit my job at that point. But before I was at LFI, I was at Mercedes-Benz. The project was winding down, and I was driving about 100 miles every day by car on I-880, which if you've ever been on that freeway, I grew up in SoCal, and people talk a lot of dirt about the 405 and the 5 in LA. I hate I-880. You'll notice that I don't put a "the" in front of it, despite having grown up in SoCal. It doesn't deserve it. So yeah, anyways, I'm going off topic there, but I wasn't able to go to Prague, so I wasn't able to, present byte swap with the changes. So we're going to get, I have to update the paper for it so that it's ready for C++23. But I've got my SID byte swap paper. I'm also working on updating retain pointer for the July mailing. We're going to have a on list discussion for that. So if anyone listening to this wants to get feedback on P0468, you can find it at wg21.link/P0468 for the
that's retain pointer?
Yes, that's retain pointer. So it's a very older paper. The paper is very out of date at this point because it was written for C++17. But it's been on the back burner for a variety of reasons, because I wanted to see how concepts were going to affect things. And I was also busy with all the other papers that I wrote for San Diego.
Tell us about retain.
So retain pointer is it's basically a more modern version of boost intrusive pointer. So boost intrusive pointer at the time came out in 2001. We hadn't learned a lot of lessons from C++ at the time. So it has a few, in my personal opinion, they aren't deficiencies, but it's just, it can't be fixed for the future without breaking old code. So I needed to start with a clean room implementation. And what I was doing at the time that I wrote it or wrote the paper rather, is I had this type where I noticed I was at the time wrapping Objective-C, so I didn't have to write Objective-C or Objective-C++. I didn't have to write I didn't have to worry about the copying of Python's data structures. I didn't have to worry about DirectX and COM. I was just doing all this stuff where everything was ref counted. And I noticed that there was a very common theme of most of them were would have an increment, they'd have a decrement. Sometimes they would have a use count value, and most of the time they were quote unquote atomic. But whether they were or not actually didn't matter, because most of the time you're just operating on an object on a single thread. And if you need to actually perform a lot of operations, you would probably do a lock anyways. So retain pointer kind of builds off of boost intrusive pointer, but I also had been learning more about unique pointer, because unique pointer turns out you can have a custom deleter. That deleter can have state, and I also was just like, one of my favorite types in the standard library is unique pointer. It's such a well thought out, well designed API. It's not perfect, but it does so much. And I was tired of having to write a unique pointer like wrapper and then write a separate increment and decrement operations set, because then I wouldn't be able to just have like a clean copy. So retain pointer is an intrusive pointer that removes the Boolean from the interface on whether it should adopt or retain by default, which if you read the boost documentation, there's, you can pass in a pointer and then you pass in the Boolean, and unless you know what that Boolean's doing, it may work, it may not work like the way that you intended it to. I think that's a lesson that I've learned, is that Booleans probably don't belong as parameters and functions. They're fine for return values. Personally, I don't think they belong as parameters, but at least not without named parameters. But with unique pointer, it has this really neat feature where if I want to, if I'm given a type def, right, like for instance, OpenCL has a CL underscore device. That is an actual pointer, right? It's a struct that's been type def to a pointer. So to actually get the actual pointer type, so that I can do add pointer t, I need to first remove pointer t and then pass it into the unique pointer. But with the custom deleter, I can do using pointer equals that type, and then unique pointer will use that type internally for storage, and then it will it will return the type that I want, which is the actual pointer, which is a CL device. And retain pointer uses the same approach. So you have a traits type, because the point of an intrusive pointer is that all the state is stored in the actual smart pointer or
right.
the object.
And that's what we should probably say, because you referenced boost intrusive.
Sorry,
and the idea with an intrusive pointer is compared to a shared pointer. A shared pointer will have a separate ref count block, which may have to be allocated separately depending on whether you call, make shared, blah, blah, blah. But an intrusive pointer, the idea is that we expect that the object itself, the type itself, has a ref count as one of its properties, which is more efficient in many ways. It also makes it really easy to get a pointer to it, because it doesn't have to find the object. But the trade-off is that the object is intrusively designed, meaning it's designed from the beginning with the knowledge that it's going to be held in a pointer like this. Whereas with shared pointer, you can make an object that knows nothing about the fact that it's shared, and then you can, that's non-intrusive, right? So that's so that's the set of trade-offs.
Yeah,
it's actually
I forgot to mention that part. Thanks for
It's more efficient to do an intrusive pointer, but it's less flexible.
Right. And one of the problems that happens is that people assume like, oh, this is a shared, like this is a type that has a reference count, I'll shove it into a shared pointer. Well, now you got two problems. It's a very common thing, right? But now you've got two problems, right? One, you've got two reference counts. Two, you've got the ability to modify the reference count of the object separate from the one that shared pointers referencing. And three, I don't know how to count. So
you should be writing reference counts in.
Exactly. So that's what happens when you retain by default. Anyways, I'll bring that up in a moment. But so there's some contention on whether we should adopt or retain by default. But that was a little joke. But anyways, so retain traits has three potential operations. Two are required. That is a function called increment that takes this pointer type, and a function called decrement. And whether decrement actually deallocates the object or destroys the object or calls the destructor is up to you, the implementer of said traits type. By default, We do have a little bit of an upgrade path for people coming from Boost Intrusive Pointer. It is not a perfect upgrade path. You do have to make a lot of changes. It is not going to be a perfect one-to-one transfer in terms of semantics, but there is an atomic reference count and a non-atomic reference count type that are added as mixins, kind of like an enable shared enable shared by this.
Enable shared from this.
From this, thank you. I couldn't remember the word.
Well, it's such a wonderful type, right? Enable shared from this.
So easy to remember, you know.
Yeah.
But yeah, so the limitation I ran into was, or rather, like I have not really run into a limitation much. However, after working around with things for a bit, I noticed that some libraries actually require you to increment the reference count. So like you'll allocate the object and like now you need to add 1 to it always. So we had to come up with the concept of retain and adopt. So retain is increment by default. So when I take this pointer in by default, I will always add, I will always increment the reference count. If I'm adopting it, it's as if I was creating a unique pointer, right? Like I just shove it into the unique pointer and I'm done. The issue that has come up is that Mark Zarin from VMware brought up that internally for their types, they want to retain by default. And I was like, that's a fair argument. I understand like why you would want that. So I had in the same way that I had to detect if there's a pointer definition, I detect if there's at the time default action for the retained traits. And so if it's not there, then I choose adopt by default. Mark's argument is that it should be retained by default if there is no, default action. My argument is most of the time, these types have been kicking around for a long time. Most of them are adopt already. So the only change that I've made actually is that I've changed it from default action to reset action because I realized also when you go to reset these objects, you also have to pass in whether you want to adopt or retain sometimes if you want it to differ from the default. And there's been some arguments. Tony Van Aert had said, well, it should be explicit every time. The problem with that is that it ends up breaking a lot of APIs that expect a unique pointer-like type that retain pointer honestly slots into perfectly. You can actually, minus, I think, the inability to copy a unique pointer, you can basically use them as the same type. Also, there's no get deleter. So, if it has to call get deleter on the smart pointer, it'll fail on retain pointer. But otherwise, these types are basically siblings. And so by requiring it to always have an explicit, second parameter in the constructor or reset, that ends up breaking that relationship between unique pointer and retain pointer. And it would kind of be like, you wouldn't like unique pointer if every time you had to build a unique pointer, you also had to construct default delete,
Mm-hmm.
You wouldn't enjoy using it at that point. And the same thing goes for, retain pointer. I don't enjoy doing it that way. So the argument, what it really boils down to is, and this isn't meant to be a dig at Mark or anyone, but like, they just don't want to have to add one line to all of their traits types. Whereas otherwise, all of us will have to then add one line to all of our traits types when we interact with COM, when we interact with Objective-C, when we interact with Python, and some parts of Mono, any JSON C library that might use it. Curl, I think, uses some reference counting. OpenSSL uses reference counting, right? And all of these are required to adopt by default because you're constructing them, and rarely are you retaining them when you construct it. So that issue ends up that's honestly been one of the biggest issues, and we're going to have probably a huge discussion about that on the mailing list at some point on the internal reflector. But my personal opinion is it should be adopt by default, because then all of us have to write less code, even if it means that this one library at one member of the committee has to write one line of code for a few types internally.
Well, I trust that it'll all work out because C++ has such an amazing history of getting the defaults right all the time.
Well, that's actually been a huge back in San Diego, I had proposed us adding a std arguments and std environment type, so you could get the current like processes one. And I was like, this needs to be UTF-8 by default. And so it was in SU16, and Cornton at the time was like, but we never get the defaults right. I'm like, I don't care. I will not put this paper forward unless we get the defaults right. And he just like sat back like, whoa, like you're crazy. But like I just because we got the defaults wrong before doesn't mean we can't get the defaults right now. It's 2020. Like we can move beyond our mistakes, I think. Even if they are ABI related. Although like I have some ideas on how to tackle that problem, but it just puts more burden on implementers. So they're not going to like it. But it would be a solution to permit user-defined extern mangling of symbols, which sounds terrifying on the surface, but I would need to write it down into a paper. But the gist of it is, if you're using C++ 17, you'll link against the C++ 17 symbols. If you're using C++ 20, you'll link against the C++ 20 symbols. And if we ever have to do an ABI break, well, then that's just a hard stopper. And if someone needs to do a conversion between them, then they can do that. But it's not a simple problem to solve, obviously. But it is, in my personal opinion, if we don't do something about this ABI stuff, we are going to regret it, because the longer we wait, the longer or the harder it will be to fix it. And additionally, at some point, someone's probably just going to fork the standard library and just like ignore most of the language. And if a majority of people aren't using the standard library, then you end up with a situation like the D language had, where you had the D language's standard library, and then you also had Phobos, which was the community standard library that everyone recommended that you use. And while they were able to fix that with D2 by breaking the ABI and changing a lot of things, like that's not a thing that we can do in C++. So, our options are be ABI stable forever until the heat death of the universe, or people just won't contribute to the standard library anymore. And if we don't have LEWG and LWG, then like what's the point of having most of the community in the first place?
Well, it's a tough. I mean,
Yeah.
it's a tough call. But I tend to agree. I think that a predicted pattern to say, okay, well, every other release, every 6 years, or even every 9 years, but to set it down and say this is what's going to happen, and you can plan for it now, and this is what your expectations should be. I think that may be a sane approach. Although I completely understand the idea that people, are in situations where they have been purchasing libraries where they get them as and binary only or something like that.
100% as well. The thing that I have found, which like I've been more in the web space lately, and the thing that I have found is that because other languages break stuff on like even minor releases, people think that you can't compile C++ 17 against C++ 11, that you had to have everything be the exact same version. And like, that's true for stuff like cars, where you have to have a compiler that is certified. So you can't just mix and match compilers. So like, it's fine there. But, I was interviewing while I was at Mercedes. I was actively looking for other positions because I was like, I know this project's winding down and I don't want to keep having to drive 100 miles every day. And, I interviewed with a variety of places, and they were like, oh, well, we use 14 here and we can't upgrade to 17. And I was like, oh, like, what, is there like a library preventing you? No, you just can't compile 17 against 14. And I was like, that's not true. Like I will demonstrate for you that is in fact a false statement. And like a lot of them were just shocked, like, whoa, like, has it always been this way? I'm like, yes, it has always been this way. Yes, it has always been this way. And it's actually a problem because we want to fix things. And they were kind of shocked that was even the case. And so like I understand the concept of like implementers are hearing from, like when they break something, they will hear from anyone that affected. Mm-hmm. But for people that want to move into the C++ space, a lot of them are avoiding it because they think that, like, it's not that the language is breaking things every 3 years. It's that they think it's just like every other language. So they don't want to have to invest in a tool chain that doesn't have a package manager, that doesn't have a dedicated compiler that they can easily get people spun up with, if they then can't recompile everything underneath the new version of the language. Being like I had already explained at work, like before I was even interviewed technically with them, like, oh yeah, like if you're on 17, like once C++2a is available, you can just start using that right away. And they're like, oh, cool. Like, we weren't sure because it's not really clear in any of the documentation for any of the compilers that you can do that. I think people would be a bit more like fine with that, but or would be willing to invest in C++ a bit more if they knew that. But not everyone does. You have to like talk to an implementer from the standards committee to find that out, right? Like, why else would people be like, hey, here's this thing that fixes this problem, but it breaks ABI, and they're like, oh, that's an issue, like.
Yeah.
Like I didn't even know that it was like one of the biggest problems until I finally went to a committee meeting at San Diego, I guess the thing I think that we would need to do is decide, like, once we know how the feature is going to be used to allow us to break ABI or to have stable ABIs, that we need to add it to the standard and then say, okay, in 15 years, we're finally going to flip the switch. So you have 15 years to get everything set up. The tooling will be there by then, hopefully. And like, you'll be able to call back into older code libraries that, can't be recompiled or anything like that. Or maybe I'll just like give up at some point and just like at the age of 60 be like, all right, give me every compiled library that you don't have the source code to, and I will rewrite it. Bugs included. Like, I don't know, like that would be 30 years from now, but still, like, who knows? Like, maybe I just wouldn't care anymore at that point. So it's
I know when I talk to people very often, they assume that a compiler is going to have a flag, and you'll say this is compile this with 11, compile this with 17, compile this whatever, and they're really surprised to know no, the way most compilers are working, when they introduce new features, they're just on, because there's no backward compatibility issue on that. If your syntax doesn't ever use whatever, if you don't ever use a Lambda, then it doesn't matter if your compiler supports Lambdas or not. If you don't use it, it's just not there. We talk about those corner cases where we actually break code, but they really are corner cases. I mean, it doesn't happen much. And almost
way more than I probably should have at this point. So like, I know the consequences of making a one-line change to update something to 11 and it breaking ABI. When I was at Apple back in 2014, they were using a library I'd written, which like you had known about, which was minimalistic core at the time. And I had my observer pointer, and at the time I had written it, equals default didn't work on GCC 4.8 because they didn't fix that until I think like 4.8.1 or something like that. So then it happened that I hadn't done equals delete for the default constructor. Well, I changed it from empty braces to equals default. And then we suddenly started getting, whenever we would construct one of these, or if it was coming from a library that had used it, but it hadn't been recompiled with this header only library, it would link just fine, but then it would crash. And it would just segfault because it was basically writing a pointer's worth of zeros to the stack and was just doing a stack overwrite. Now, granted, that could have just been a GCC 4.8 bug, because I found other things with that version of the compiler where it would zero out a std vector for no dang reason, which infuriated me beyond all point, because I had written a JSON parser from scratch, and at the time, Synergy JSON wasn't a thing, and Llama JSON wasn't a thing. So and I was beating out Rapid JSON by a decent percentage, but we couldn't deploy the code because we weren't on 4.9, which it worked with, and it worked with 4.7, but it didn't work with 4.8 because it would just zero out this one std vector in this one line of code, and we couldn't figure out why. So it was also should note, like, at the time Apple had banned GCC, but this was a team that had been purchased.
Yeah, I was going to say that GCC at Apple
until but they couldn't move over to Clang because the code wasn't ready yet. And I think when I left, they had just moved to Clang. back in 2018. So yeah, so I'm very well aware of this, like the small corner case stuff, but it's
But that may be that's less about the language incompatibility than just a particular implementation, a particular tool with a particular bug, and
right.
The quality in general of compilers is so high that it's one thing that particularly when you teach beginners, they're really quick to think there must be a bug in the compiler because my code couldn't possibly be wrong. It couldn't possibly be, this bug can't be mine. It must be the compiler's.
My coworkers thought that I was doing that classic thing of like the compiler must be wrong, because why else would this code be generating poorly? And I was like, no, like I know for sure that my code is correct. I'm like, but your code doesn't work, so it must be you. And I did two things. One, I pulled Linus Torvalds like massive rant of why you shouldn't, like why GCC 4.8 was banned for compiling the Linux kernel because of code generation bugs. And then I also showed them, here it is compiling with 4.7, here it is compiling with 4.9, here it is compiling with trunk. Look at compiles with Clang 3.3, 3.4, 3.5, 3.6. I'm pretty sure this is a bug in the compiler. And then I found the actual issue on the GCC tracker, which is not the most easy to browse thing.
Yeah.
Posted that in an email, and they're like, "All right, fine. Like, well, you're right. Jeez." I was 25. I was a little angrier at the time.
Well, I think I said it on this show even that the more experienced you are as a C++ programmer, the more likely you are to actually find a compiler bug, and the less likely you are to assume it is a compiler bug.
I've absolutely destroyed compilers so many times. Like one time I found a bug with Const Expert and Clang, and it was such a deep level of a bug that when I submitted it to the Clang team, to the internal bug tracker, the message I got back was, "Listen, I'm busy for the next 6 months. I do not have time for a deep dive into Const Expert and Clang. Have you considered not doing this for your code?" And I was like, "Oh, I was just playing around. I completely, I seg faulted Clang. I just figured you would want to know." And they were just like, "Okay, but have you considered not doing this in the future?"
Is there an emoji that looks like a white flag? Because that sounds like that's what they've said. It's like, no.
There's a white flag emoji, yeah. What it was I had applied. I think I had declared an inline Const Expert static align as a line of something, like just like I put every qualifier I possibly could, and that worked. It would error, and then I put mutable in there, and it just completely crapped the bed. I was just like, I must be having like a stroke. Like, this can't be working correctly, right? And so I messaged a friend over IRC. I was like, "Hey, like, you've worked with compiler details. Do you get this bug too?" And they were like, "Let me try." And they just came back with, WTF, just like, why would you do this to me? That was the start of me doing first things, honestly, was like, oh, I managed to crash the compiler. So, and I will give the compilers credit. I have not really been able to do that since. Like, the 2014 to 2017 era of me crashing the compiler on a regular basis is very rare for me to actually get a compiler error where it's an internal compiler error now, versus like, oh, I forgot a semicolon again in the year 2020. Concepts also, oh my god, the number of semicolons you need to put in various places. We got to make them optional. There's got to be a better way.
Speaking of JavaScript.
Yeah. Speaking of mutable, there is precedent then, because mutable lambdas are not mutable by default.
Yeah.
And so sometimes we get the default, right?
Yeah.
And there's precedent for it.
Yeah. But they're not Const Expert by default, and so I'm sure
They are now.
No, you have to add the Const Expert keyword. So Const Expert goes after the parens now. I also kind of wish that the order of where to put requires, no, except, override, final, const qualifiers, And in the case of Lambda's const expr, was a bit more easier to remember than, okay, I haven't used virtual functions in like 6 months. Does the override go before or after the no accept? Well, let's try it out. Oh, got that one wrong. All right, so, oh, no, I messed it up again. It's damn. Like, just every time. It's I hate having to shotgun my own syntax is the thing, instead of like opening up CPP reference and then just like browsing to the page. But I'm just like, but I'm right here. I could just compile it. But
well, I think that trying to play with the order of keywords is not contentious at all. I think Phil and I are both well aware that people have no strong feelings about this and are willing to go with the flow, whatever the code base is.
Actually, John, I have a really important question for you. So I know about the whole, East const west argument, but have you considered East volatile versus volatile west?
I think that the logic for that, the arguments mostly would fall down that it should be treated the same way.
You'd think, but the Clang format people, it turns out, had to have a huge discussion on whether they wanted to go with East or West. And then they're like, but wait, what about volatile? Well, it should follow the same one. But what if we don't want it to? So I'm now an East const volatile West kind of gal. So
real-time update, according to CPP reference, for lambdas, the function call operator will be const expr anyway if it happens to satisfy all const expr function requirements.
Oh, interesting. That is not what I remember
since C++ 17.
Oh, well, you learn something new every day.
Yes, and
we actually fixed the backwards default there.
Wow.
How about that?
Was that a defect report or was that just a feature change?
I don't know the history of it. Just remembered that coming in.
Now, if we can just get that for every inline function, then
well, I'm working on that.
My favorite thing is you would probably have to get in touch with Bryce about this because he was the one that mentioned it, I think, in a summary post from Prague. But I think with modules now, functions that are defined in line, like they would be in a class or in like an interface module, are not in line by default anymore. I think they are technically not in line, and that's for code generation reasons. So I think you're going to have to start peppering inline around your code if you start to move to modules.
Is that the inline attribute?
Inline the qualifier.
Right.
But that doesn't mean that.
Doesn't make it
inline doesn't mean inline. Inline means is safe to be in the header multiple times. That's what inline actually means, right? Right.
But with modules, you can't really do that.
But you don't need it either with modules, right? I mean,
well, if you want to special, well, this is also another thing too, which I want to fix extern template and I can't because it's just spread across the standard in like 30 different places. But Victor Bull in the chat here. Indeed, in-class method definitions are no longer implicitly inline. Yeah,
that's only true for within a module, right?
If it's in a module, I don't know if it counts if it's in a header that you then import into the module. I'm sure someone can like probably expand on that later. But
the Colby's typing, so.
Yeah, Colby's typing. Give us the answer, Colby.
Chat's 10 seconds behind us.
Do the work for me, thanks.
Right. They're also he and John Heat are also arguing about whether it should be
oh yeah, no, I saw that.
T ref space A or T space ref A.
Yeah.
Or T space ref space A.
Yeah. Yeah, traditional T is still in there. Yeah. So that was a change that I was surprised at, but I honestly welcome it because it actually makes my life easier with regards to extern template, because right now, extern template, aside from the other issues that I brought up with it in a different paper, So I'm wrapping OpenSSL for C++ right now. So it's the C++ 20 capable library. And the problem I've run into is that I need reflection over names of functions so I can generate the actual function name, but I have to use a preprocessor. So I need to basically generate a traits type based off of the name of a type, and then it generates this one class. But I don't want to define all those functions in line because they're actually not available. I had to include a separate header for them. So I just want to declare this traits type, but I can't then say extern template this partial specialization of a template and then define that template specialization and instantiate it in a separate translation unit. I have to instead extern template that that class after it has been defined. And it would be really cool if I could just not have to do that, but the compiler will complain otherwise. I also think it's technically an IFNDR under modules, but there's Also, Colby, you keep using that keyword. I don't think it means what you think it means. Inconceivable. Inconceivable.
Inlineable.
Yeah. But yeah, the multiple times in a TE thing has changed because of how modules work. This was an issue that was brought up when we were discussing, how do you have, because we can now do, namespace, name, : name, : name. But what if you want that second namespace to be inline? And Alistair had, stated like, let's have it be : inline name. And honestly, I can't think of a better option. So I was fine with it. And I was like, that's fine. And I can't remember who it was that brought it up. I just know that they work at MongoDB. I can't remember which of the four people that go to the standards meeting mentioned it, but they were like, well, you could just forward declare it and then just reopen it later. And I was like, that's not going to work with modules. And I know for sure it won't. And it turned out that, you can't technically, you can't declare a namespace and then mark it as inline later on under modules. You can currently kind of sort of do that. Clang will complain, but it won't freak out about it. So you can just do -w no, right? But that solves all problems, right? -w no everything, problem solved. But then it would break underneath modules and it would be undefined behavior, as well as I think it would be an ODR violation as well. So it ends up being a pain in the butt. So such is life.
Well, we should probably start to wrap up here, right?
Yeah.
But it's been great having you on. It's too bad we couldn't get you to say anything controversial, but maybe next time, right?
Gonna be like, wait, is he fine with modules? So
I guess that's the breaking news.
Yeah.
Is he now fine with modules?
It'll just be like a quote from people that use it. It's just like, it's okay, I guess. Izzy Muerte. It's all right.
Or we say Izzy fine with modules, but fine in quotes. Yeah, I'm fine with it.
Only this the camera, but just like a massive air quote.
All right. Well, as I said, it's been great having you, and join me and Phil in wishing everybody safe coding, particularly in this wonderful time of COVID.
Safe coding.
Safe coding, everybody.